back to the Genome Design YouTube channel, where if you've not been here before, we take you through the process of tuning various different ranges of Porsches. Now, in this particular video, we're going to be talking about this 992 Generation 1 3 T GTS. Now, in my opinion, this particular car is the sweet spot of the range. So obviously you've got the Turbo S, which is vastly more expensive. And then you've got your GT product cars, which are mostly for the track. This gives you a bit of a blend of the two. So we've got the 3 litre twin turbo engine in this, producing 470 horsepower from factory and 420 foot-pounds of torque. Now, in this particular case, we're going to take this car to a stage 1 tune. So we're going to put drop-in panel filters and then our ECU and PDK calibration. So whilst we're heading down to HQ in this GTS, getting ready to do our stage 1 tune on it, thought I'd touch on the idea that, like I mentioned before, this, in my opinion, is the sweet spot for the range of this 992 model. For somebody who's going to use the car every day, you're getting turbocharged sort of torque delivery, if you like, that the GT cars are missing, but the Turbo S has. And then you're also getting some of the stripped back fundamentals of having a GT car that you wouldn't necessarily get with a Turbo S, because it's supposed to be very fast but also very plush. So these newer cars come with an aero kit on it, which you'll see on the video. Again, just makes them look so much better than the Generation 2 991, which is what I have. One of the things that I picked up on straight away is that I'd like to have a wing on it, but they didn't offer that on the Gen 2 991. On this car, obviously, you've got something that looks similar to a GT3 wing, and you've got the front aero and the big wide arches, which you can see in the mirror there. It looks lovely. So they've really nailed it in terms of it looks special, it drives special, feels nimble like a GT car, but at the same time it delivers a massive amount of torque in comparison to a normally aspirated engine. Furthermore to that, you've got the various models within the range. You've got the base model, obviously, and then you've got the S and then the GTS. Similar to the 991 Gen 2 platform, they have changed turbochargers for the GTS. That's why it's producing such good numbers, even standard. The benefit of that is that they've got big turbos, but they're also limited in the way of how much they want to output from this car. Otherwise, it's going to be competing with its bigger brother, the Turbo. Now, obviously we're going to see later on in the video, but I'm expecting to see somewhere in the region of, well, I speak in wheel horsepower because of the type of dyno that I use, so I'm aiming for somewhere between 480 and 500 wheel horsepower, which would equate to somewhere in the region of 560 to 580 horsepower at the engine, depending on what correction factor you use. I'm also expecting to see the torque jump from like 420 foot-pounds to somewhere around 500 foot-pounds as well, and that's going to be using relatively low boost pressure. So when you consider that against like a turbo, for example, which is obviously a considerably more expensive car, and it doesn't necessarily have the big wings and the sort of feel of a GT product, it's much more designed to be a everyday used car that's plush but extremely fast. Whereas this definitely does feel more pointy, it's a lot stiffer, it feels more like you're driving close to a GT3 but with a turbocharged engine. I expect that when you have 500 wheel horsepower or in the vicinity of that, put this up against a turbo, and I don't think there's going to be a great deal in it until you get higher up in the rev range, or at higher speed, should I say. So we'll head on down there now, we'll make a start on the tuning process. The first thing we'll do is load it on the dyno, get some initial data from stock runs, get an idea of where the car's at from standard, make sure everything's healthy before we make a start on demanding more from its components, and then we'll start to turn it up. So as you can see, we've now loaded the car to the dyno with the intention of doing some stock runs. Some people will be wondering why we've removed the back bumper on this car, and I just wanted to touch on the reason behind that. So if Steve can follow me, essentially on the 992 platform, as you can see here, this is actually a backside of the intercoolers. So they're a top-mounted intercooler, and the airflow comes over here and is directed in to a degree. Now, that's fine when you're going down the road. However, when you are stationary on the dyno and our fan is at the front, something if you've watched any of our videos, you'll already know it's really difficult to keep them cold. One of the safety features in this ECU that we continue to use even when we've tuned is that as the charge temperatures go up, the torque request gets pulled out after a certain degrees in temperature. So for example, once we start getting towards 40 plus degrees intake temperatures, it slowly starts, and as it goes up to 60, it starts pulling it back down, back down, back down. So you'll almost, if you ran this on the dyno without these extra fans that we're going to show you in a second, because of the nature of where our fan is at the front and it's not getting enough airflow, what you find is you start hitting those safety features and it backs the car almost back down to stop. So what we've done is we've improvised and used one of the lads in the engineering side who's 3D printed us a top mount, so basically So you've now seen the car run up in standard form. Now it's important to note that we've actually fitted a BMC panel filter kit to this. We fit that to pretty much every car that comes through the door. And what you can see here is the stock graph. Now the blue line is the power at the wheels, and we'll use a correction factor based on what Porsche quote to see where the engine figure is, but usually it's between 10 and 12%. So what that means is if we've done 425 at the wheels, which is what we've done here, if you take a 10% correction factor, that's just over it's only just over 460 horsepower, but at 12% that's 470 horsepower, which is exactly what this car should come from factory. So that means that it gives us a delta when we've finished tuning the car, that we can add that 12% to the wheel horsepower figure to give us an engine figure or there or thereabouts. The reason that we have a hub dyno is, first of all, what's most important is what's transferred to the actual road through the wheels, but secondly, it's safer for the lads and it's a more accurate result when we're doing consistent dyno pulls. We use this dyno for a lot of R&D before we release production tuning. So in terms of 425 horsepower at the wheels, that is at 12% correction, right around 470 horsepower, which is what they quote from factory. And as you can see here, the torque figure is sitting right around 420 foot-pounds as well, which again, that is what they quote from the factory. So this car's bang on. It's exactly what you would expect from the factory. It's hitting exactly the numbers that they quote online. All I need to do now is jump across to my laptop, which will do that, and we'll go into a little bit of depth around what the data logs are telling me. So that'll tell me throttle positions, how much boost pressure are we running, what's the ignition timing doing, is it trying to pull any ignition out of stock, blah, 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 blah. So we'll go across to that now. I'll talk through some of that stuff. I'll then build a stock base file for the guys to run, and then we'll sort of look to see whether it needs turning up or coming backwards a little bit from there. So the first thing that we need to do is check the stock logs. I'm not going to go too into detail on this. We'll probably do some, as I keep saying, we're going to do some more in-depth videos around the data logging, but I do just want to show people some of the basic things that need to be checked prior to us moving into the tuning process. So first things first, we want to see from stock what the throttle position is doing, and on this particular car it's pretty much wide open. It comes on nicely down here, starts to open as the car comes on boost, and then it's at wide open throttle all the way through. Now, quite a lot of the Porsches are set up like this, turbos in particular, gives a throttle plate. So when you're at 100% throttle on the pedal, the throttle plate actually opens a bit slower, and it tends to be for various reasons, but one of the most important reasons is it gives it something to build boost against, so it brings them on boost a little bit quicker. So it's a really nice way of doing it actually. So we'll leave that alone, we won't mess around with the factory throttle control on this car. Ignition reduction on this particular car, in stock form we are seeing some up to about 3.75, yeah, 3.75 again there and 3 there. So it's not horrendous, but there is 3 degrees of ignition pull. So realistically, when we start to turn things up, we just need to keep an eye on it and make sure that what we've adjusted is working correctly. In terms of boost pressure, this is the most important one that we're going to change. If I can just find the boost pressure commanded and boost pressure actual. So as it comes up to peak cylinder pressure, this car's hitting right around, it's commanding 1.3 bar and it's hitting 1.322, so it's around 1.3, it dips a little bit there and then comes up to meet its maximum boost pressure, which is just below 1.6 bar, and then right up at the top here you're at 1.46. So it's pretty low. We know we can definitely run more than that, but I don't think we're going to need to go crazy to get what we want. So I'm thinking somewhere in the region of 200 millibars more of boost pretty much everywhere. A couple of degrees of ignition time in advance and see if it pulls that back out. If it pulls that back out, then we've really got no choice but to go back to the stock timing. So we'll make a few changes in Winnows now, which I've got open here. I've already built a base file for this car. We've already made a few changes, which again, I won't go into too much detail, but mostly based on torque requests, RPM limit changes, fueling changes, more torque requests changed there, and then various limiters that we need to lift to make sure we're not going to clip those. Make some light changes to the some of the safety features here where we need to lift the boost a little bit. And as you can see, we've retained, so when the car starts to get hot, we've retained the reduction in engine load based on intake temperature. So basically what that means is if the car starts to get hot as a result of the extra boost, it will continue to back it off. So we've got various things done there. Ignition timing wise, if I can just skip along to it, I'm going to add, where are we? The torque limits, there we are. So we've gone somewhere in the region of starting at 0.75 of a degree added at 1000 RPM, all the way up to adding 2.25 degrees, which is not massive. We would usually put 3 degrees in, but as it's starting to pull some already, I just want to test and see if it's going to pull that straight back out. If we go from pulling 3.75 to 5.75, then we know that it's just pulling the timing straight back out that I'm trying to add, in which case you've either got the option of relaxing the knock control to allow it to make that timing, or unfortunately going back to stock timing. So just see how it responds to what we've got there. So we'll send that through to the lads, get an idea of where we're at, and then we'll decide whether we need to make a revision. Okay, so as you can see behind me, we have now got a tune file run versus the stock run. So you've seen the car run up on the dyno again with our tune file on. Couple of things to note on this. Obviously we are battling heat, even with the extra cooling fans. It's not the easiest thing to keep cool when the engine's in the back. However, we've still got a really fantastic result. To be completely honest, if the data logs look good, I'm quite happy with where this is from a power and torque point of view. I'm not looking to turn this up anymore with the hardware that's on the car. Really, we'd need to put some downpipes and manifolds and bits and pieces to go to the next level up. So from a torque point of view, we're just clipping just below 500 foot-pound of torque. I suspect if we could keep the car a little bit colder, it would go above 500 foot-pounds. So it's a massive jump from where it was standard. As you can see here, the delta between the dotted green line and the solid green line, which is stock versus tuned torque, is consistent all the way through. So we've not only just made a quick 500 foot-pound of torque and then it drop off, we've actually managed to hold a considerable amount, somewhere in the region of 80 foot-pounds of torque, almost all the way through the rev range. Same goes for the power figure. We've ended up at 511 wheel horsepower, which by my calculations, which I should have done before we started the video, I'm going to add 12% to that, so 511 times 1.12. We've got 572 horsepower at the engine is what you would quote based on the stock figures. So I prefer to know what the wheel horsepower delta gain is, which is just short of 100 wheel horsepower. Tremendous results from a car with just an air filter in it, essentially. You might notice at the top here where the power figure drops from 511 wheel horsepower down to about 450, and then obviously we hit the red line. This is the gap here, if you can see it on the camera, is purely because we've upped the rev limiter slightly. We'll have adjusted the over rev counter as well to make sure that there's no over rev limit 1. So we've adjusted all that, but the reason that it's dropping from 511 wheel down to 450 quite aggressively here is because right at the very top of the run, even as you've probably seen, we had to pull the fans out to be able to get the cameras in. So as it gets to here, the limiters that I was talking about, the safety features, we're just clipping those. So we're just starting to see above 40 degrees of intake temp is what I would imagine, and it's starting to back off the torque request to make sure that the car's safe. It won't do that on the road, and if we were to put more cooling into it, you'd probably find that this would just settle off right around here and just keep around up to about 470 to 500 wheel horsepower, and it'd fill it out nicely. But by seeing that means that what we've done is right, because it's picking up the fact that it's getting warm and it's backing it off, which is lovely. So with that in mind, let's jump across to the laptop again. We'll have a look at the comparison of the data logs between stock versus our tune file. If everything looks healthy in the data logs from the tune file, then as far as I'm concerned, we don't need to push for any more and we don't need to turn it down. Okay, so we've now run the car up, and as you've seen, it's made a considerable gain in power. But what's really important is us being able to sort of testify what we've done based on the logs. So we're now looking at the tuned log file versus the stock file log. So we can basically see what the differences that I've made are. So we've now got just short of 1.5 bar, so 1.45. So we've gone up just about 150 millibars there where it meets peak cylinder pressure. We've got a little bit more time in there. It has accepted the timing, which is good. And then it ramps up there to peak is about 1.8, but it only just touches that. It's mainly underneath that at around 1.75, all the way up to 6,000 RPM, where it then starts to tail off the boost nicely. But again, we're still at 1.6 bar in comparison to the standard graph, which I have open still somewhere. There we are, where we were at 1.438. So we're not massively more, but what it has done is it's accepted. We've pulled less timing out. So if I open the knock control up, so the ignition timing pull we've only pulled 3 out there instead of 3.75, and that pretty much goes down to 0 all the way through the rev range. Now I haven't adjusted the knock control on this. What I have done is added some fuel, and it seems to have enjoyed the extra bit of fuel, stopped it knocking, added some time in, and that has given us a really fantastic result. So we've managed to get the result that we have without going crazy in terms of boost, but adding a little bit of fuel has allowed us to keep the knock control in a more happy place. And as a result of that, it's not pulled the ignition timing out. So we've had with the ignition timing that was originally pulling out has now been added in, then a further 1 to 2.5 degrees pretty much across the rev range, and you can see that here. So we've got 12 degrees right up at the top there at 6,500 RPM, whereas on the stock graph it peaks at, let me just get to 6,500 RPM. Where are we? Come on. Where are we? Engine RPM, there we are. 6,500 RPM. It's at 8. So it's added the timing it was already pulling out, which has taken it towards, will have been around about 10 degrees, and then it's taken an extra 2 degrees of our timing that we've put in, so 4 in total. So that's how we've managed to achieve such a great result. So what we really need to do now is get the car on the road. So we need to go out, log it on the road, test every part of the part throttle stuff, and make sure that we've not got any engine lights coming on, any weird part throttle mishaps, any misfires. with a different amount of load that you see on the on road driving, we need to make sure that that matches what we're seeing on the dyno as well. So that's the GTS now complete and back with the customer. We're absolutely thrilled with it. I've already had text messages from the customer saying that he's really happy with it, so that's great news. We're about to move on to this 718 Cayman, which again is a popular platform for us. If you want to know more about any of our Porsche tuning, jump over to the website, reach out to our team. Definitely subscribe to the channel because we're going to continue to do this, and we'll look forward to seeing you on the next video.